Hello, dear colleagues and professors. I'm going to present. I'm sorry, switch the screen to the presentation. I'm going to present today on behalf of Civil Engineering Department of Istanbul Cultural University, Istanbul Kültür University. So today the title will be the life cycle cost analysis of radiant heating and cooling system integrated with air source heat pump. So buildings are inarguably one of the largest energy consuming industries. According to the International Energy Agency, the average energy consumed by buildings represents 32% of energy consumption worldwide. The European Union energy consumption patterns reveal that buildings are the largest energy consumer, using about 40% of total energy demand in Europe, followed by industry and transport, each consuming about 30%. So buildings can offer the largest and most cost-effective potential for energy savings. The carbon dioxide emissions in Turkey, with the rapid development of industry and economy, so the CO2 emissions is increasing rapidly as well. So in addition, almost all of the oil and petroleum oil is imported from outside the country, unfortunately. Therefore, a plan to reduce heating energy in construction industry should be discussed. It is therefore important to analyze the life cycle cost of a building with radiant floor or any renewable energy system, such as in this case we will talk about a radiant floor panel heating and cooling system, to develop a heating cooling system for maximum energy efficiency for buildings. So to talk about the history of radiant heating and cooling, there is anecdotal reference to early 8th century radiant cooling. It was used first in Mesopotamia, modern day Iraq, in Turkey. At those times it was in the reign of Turkey. So people were using cooled water or snow-packed walls to cool the inside the living zone. And much later in the 20th century Europe, after the war, second worldwide Second World War, the Bank of England got a nice new hydronic radiant heating system. The plate and board-like members with an elongated space for holding tubing is provided as a modular pieces in line attached to the subflooring for radiant floor heating, or the wall studs for radiant wall heating. So this design I'm talking about was proposed in a patent in 1999. So throughout the history, it was well developed until this time. So in 2010, Mir hybrid wall company also designed a radiant heating and cooling system that heats the surfaces of floors and walls. So surfaces slowly radiate the heat, mostly through radiation in the system. So modern radiant heating and cooling systems, hybrid radiant wall panel systems, are a lightweight composite structure consisting of a glass fiber reinforced concrete, precast concrete, in another word, for surface heating and cooling. So this panel was filled with low density, thick foam concrete and PEX pipes, like 10 millimeter diameter pipes, with oxygen barrier embedded in the foam as well. So this design can be used also as a facade cladding system. Hybrid wall systems also contribute to heat and sound insulation. In addition to being light, flexible, and low cost, it also contributes to building resistance against earthquake, like fire resistance. It also provides. So GFRC structure of the system can prevent from breaking and bending of hybrid wall inside the wall. So this panel can protect the building from earthquake and fires as well, because fire resistance of the system increases the melting point at 170 degrees Celsius, surprisingly, as it creates steam at high temperatures, and this steam also creates ducts, reducing the risk of fire. And also insulation layer inside the wall panel, heat losses can be prevented behind the panel. Unlike air conditioning systems, radiant panel air conditioning systems, uh, I mean, unlike conventional AC systems, the do not have radiant systems do not have high air movement, and they also do not have high energy expenditure for cooling, and conventional transmission may also disrupt comfort of human, but this doesn't exist in hybrid radiant systems. Instead, there is radiation in the system, which is most suitable method for human comfort, with ceiling and wall temperature close to the ambient temperature with minimum air movement. Classical systems provide an air movement where humans can only receive maximum 30% heat. So, however, humans receive heat with 50% radiation. Therefore, classical systems do not contribute significantly to thermal comforts with very low radiation rate. However, hybrid radiant panel heating and cooling systems with integrated heat pump source offer the most ideal comfort conditions for people, with around 70% radiation and around 30% air movement. So these findings were revealed by Zhao et al. In 2016. So the renewable energy resource usage has not become widespread, unfortunately, in Turkey rather than Europe due to the high initial investment cost. Therefore, in order for the use of renewable energy resource to become widespread, it is necessary to reduce the initial investment costs and increase their efficiency, the operating costs. For this, it is necessary to choose heat emitting systems that are compatible with energy generating renewable energy systems with a holistic perspective and increase their efficiency. So within the scope of this research, we will conduct both experimental and numerical examination of the integration of air source heat pump with a radiant heating cooling system, which is capable of low temperature heating, high temperature cooling as a heat emitter system. So we plan to use such system. We will plan to increase the performance of the heat pump as well as the radiation-based heating cooling system. So therefore, we will try to generate a synergy by integration of both systems, both heating cooling systems, and the compressor capacity of the heat pump. In other words, the initial investment cost, operation cost, will be hopefully reduced due to the energy efficiency to be achieved. So, when talking about life cycle cost concept, the cost of obtaining a product is 30% of the total cost of ownership actually. The rest, the 70%, is the operating, maintenance, spare parts, and other financial costs. The conclusion we need to draw from here is that when buying a product or a system, the issue we need to solve or focus on during installation is the cost that will arise during the life cycle after installation rather than the initial installation cost. And the fact that they are predictable. The competition of product developers against their competitors to be superior against them or each other, we need to help them minimize the lifetime costs or life cycle costs. At this point, life cycle cost concept comes to the fore in controlling a product's lifelong maintenance and operation costs. So for this purpose, we will use a radiation cooling system or radiant heating and cooling system integrated with an air source heat pump. We will apply this combined system in a real scale to real office building with an area of approximately 2,500 meters square. The initial investment cost will be also calculated in detail, the operation cost as well, including the heat pump electricity consumption, like heat pump performance and building heat loss gain will be also measured and calculated from the data we shall obtain from experiments. In addition, we will also do a transient thermal analysis using some simulation softwares like Transys or Energy Plus. The building will be used as a model in a computer environment under actual operating conditions. We will simulate the experiment, so for a long time we can obtain data rather than conducting experiments for long times. So we will obtain both theoretical and experimental data from simulations and experiments. So we will do life cycle analysis, cost analysis. Of course, we will compare the simulation data with the experiments. So we will try to, you know, try to use the correct data from simulations, of course. Life cycle cost analysis will be conducted for the proposed system using the measurement and the computed data. The outputs shall contribute to the spread of the proposed system and be used in decision making at the end. Life cycle cost is generally not taken into account when designing, selecting heating, ventilating, air conditioning systems or HVAC systems. Instead, calculations are made on the initial investment cost. However, especially when evaluating the energy economic performance of renewable energy systems, system life cycle cost should be taken into account. When a realistic life cycle cost analysis is conducted, it will be seen that renewable energy systems are both more economical and more environmental friendly in the long run. Thanks for your valuable time. The message I will give for today is this. So thanks for listening.